All right, so now let's talk about perpendicular lines. So these type of lines look like this. They perfectly cross each other and make a right angle, which we'll talk about later in this course. All right, so perpendicular lines have slope that are negative reciprocals of each other. So if M1 is the slope of one of the lines, then the slope of the other line must be negative 1 over M1. So basically, you flip the slope and make it negative. All right, so question 5 says, determine an equation of the line through the point negative 3, 1, which is perpendicular to the line 2x plus 4y plus 7 equals 0, and graph the equation. All right, so first things first, we know it's perpendicular to this line, so first let's find the slope of the line that's given. All right, so to do that, it would be nice if it was in slope-intercept form, so we can pull out the slope right away just by looking at the equation. So that means we need to solve for y. So first, I am going to subtract the 2x from both sides. I'm also going to subtract this 7 so I can get the y by itself. And then divide everything by 4. All right, so we get negative 2 over 4. I'm going to simplify that to negative 1/2. So just by looking at this, we know the slope of this line. So the slope of this line is negative 1/2. Well, our line that we want is perpendicular to this line. So let's figure out the slope of our line. So that would be our second step. Our slope, it's the negative reciprocal, so that means we're going to flip it and make it negative, and so making a negative negative makes it positive. So we're flipping it, 2 over 1, which is just 2. It's not going to be negative anymore. All right, and then finally, we need our equation. So I'm going to use point slope again because we have a slope, we have a point. All right, we don't know anything about an intercept, so let's just use a slope and a point. Going to squeeze this in here. So remember, it's always y minus our y value equals our slope, x minus our x value. All right, got rid of that double negative. All right, so now all I have to do is distribute this 2 and then move the 1 over. I'll do it in 2 steps. Add the 1 to both sides. All right, and so now we know exactly what the slope is. We have the intercept. We can graph it. But first, let's make sure we answer the question. The question says, determine an equation of the line through the point that's perpendicular to that other line. All right, so note, when it says something like determine an equation and it doesn't say what kind, it's typically the most popular kind, which is slope-intercept. Y equals mx plus b, which is exactly what we found. So we found slope-intercept form. Now we can graph it. Okay, so we have an intercept, so we know where it crosses the y-axis. It crosses at 7. And then our slope is positive 2, so that means we're going to go up 2 over 1, because 2 is the same as 2 over 1. But note, there's no more room on my graph here. So 2 over 1 is the same thing as negative 2 over negative 1 because two negatives make a positive. So I'm going to go down 2 and left 1. Go down 2, left 1. And that will give us the same line as if we had gone up. So we did it. We have the equation of our line, and we graphed it. Okay. All right, so our final topic is average rate of change. So average rate of change is very similar to slope, but we can figure out the average for any function. So remember, our slope formula just works for lines, but now we're going to be able to do it with things that are not just lines. So it works the same way, the change in our y values over the change in our x values. All right, so this should look familiar. Looks just like slope of a line. All right, so something interesting here, we're now switching from points, x, y, to functions. So what happens when you plug x2 in the function? You actually just get the y value f of x2. When you plug x1 in the function, you get the y value f of x1. So these are the same. All right, so note average rate of change needs 2 points, just like slope does. We need 2 points. So let's look at number 6. Given the function defined this way, x squared minus 1, determine the average rate of change from x1 equals negative 2 to x2 equals 0. So one thing I want us to look at, we got an x squared here. This is not a line. This is not a line. It's actually a parabola, but we'll study that next. So we can't find the slope. But we can find its average rate of change. Okay, so let's do that. I'm going to use ARC for average rate of change. All right, so remember the formula is our function at x2 minus our function at x1 over x2 minus x1. So y values subtracted over x values subtracted, just like slope. All right, so what's x2? x2 is 0, so we need f of 0. x1 is negative 2, so we need f of negative 2. Well, how do we find f of 0? Well, we plug 0 into our function minus, we need to find f of negative 2, so we plug negative 2 in our function. Oh, this is a minus a negative 2. Which is going to make a positive 2. All right, is everybody with me? All right, so now we just simplify. So this is negative 1 minus 4 minus 1 is 3 over positive 2. So the average rate of change here is negative 2. All right, so make sure that you can answer yes to these learning outcomes checks, and if not, make sure you ask me about them in class.